This is a topic that affects every family and every community, and, but importantly, every future generation. The discussion centers on developmental origins of health and disease, or DOHaD. This is a very simple, but it's a very powerful concept. Now, we've all heard of NCDs, non-communicable diseases, and there's a good chance that many of you in this audience will have at least one major NCD. But how many of us understand the implications of the NCDs we have for our unborn children and grandchildren? We all try and follow healthy lifestyles, exercise, diet, etc. But how many of us understand that it benefits not only us, but our unborn children and grandchildren? That is what DOHaD is all about. Today, I'm joined by two eminent colleagues and Professor Balakrishnan and Dr. Naveen Ramesh. I won't reiterate their bios. So I will begin by presenting an overview of DOHaD. So I thought we should just, this is really just an overview. I have a disclosure at the beginning. I'm not an expert by any means in this area. I have done no work myself. I mean, I have no personal experience, but I just think it's really important that we try and understand this. And I really want to present it from an Indian perspective because there are certain unique aspects of DOHaD in India. What is DOHaD? It refers to the link between early life environment and lifelong health and disease risk. And we really have to be grateful to this man, David Barker. David Barker was a physician and epidemiologist who worked in Southampton in the UK. And he formulated the Barker hypothesis in the late 1980s. What is the Barker hypothesis? Well, it was based on work that he was doing in England and Wales. And he found something quite remarkable. That is that there was a strong link between low birth weight in communities that he looked at and death from cardiovascular disease in the same community 40 years later. In other words, he looked at the same community 40 years apart, and those people who had a low birth weight had a higher risk of cardiovascular disease death. And he was very struck by this. As you can imagine, it was completely the opposite of what you would expect, because these people were not leading affluent or obesogenic lifestyles by any means. So he called this the fetal origins of health and disease. He postulated quite correctly that NCDs have their origin in fetal life. This later transmuted to developmental origins of health and disease. Now, it is all about NCDs, which have a really unique profile in India. India has a very high prevalence of type 2 diabetes and hypertension at a normal BMI. Okay, so people have a normal weight. Indians have a unique lipid profile, and it is more atherogenic. There's a very high proportion of central obesity, coronary artery disease at a much younger age, even in Indians who live abroad. Okay, and there are distinct and unique cancer profiles in India. And you don't have to look at these graphs in details. It's just to show you the three of the important NCDs: obesity, hypertension, and type 2 diabetes. And the prevalence has been gradually rising over the years. By the way, type 1 diabetes is not really an NCD. It's type 2 that is more of an NCD than type 1. Okay? And we're seeing similar trends in children, which is particularly worrying. Now, this information was taken from the Indian Express, but it's fairly accurate. In 2019, 2/3 of all deaths were due to NCDs. And there's a 22% probability of dying prematurely from an NCD in India. So it's becoming really important. This is just a graph of type 2 diabetes mellitus. This is lean type 2 diabetes. Okay, so people who don't look obese but have type 2 diabetes. This is taken from the National Health Survey, Family Health Survey 5, which is the most recent. And you can see there's a marked preponderance in the north. So there's the regional inequality. So the three questions: why has this happened? Why now? And most importantly, what can we do about it? So there are a few very basic biochemical concepts that you need to understand. One is insulin resistance. Insulin resistance is not just about diabetes, okay? There are lots of things that feed into it: genetics, sedentary lifestyle, weight, and so on. But as you can see on the right, there are a whole lot of outputs which have nothing to do with diabetes, okay? So this is one of the cornerstones of NCDs. The second is B12 deficiency. It's very common in vegetarians. Why? Because B12 is derived mostly from animal sources. There's a very high, a large number of Indians are vegetarians. So if you're a vegetarian or pure vegetarian and you don't take vitamin B12 supplements, chances are that you're going to be B12 deficient. So India has a very high prevalence. And as you can see, it's not just about anemia. There are a whole lot of problems that you get from B12 deficiency. But the two most important are hematological and neurological. Now, this leads us quite nicely to the folate trap. And what is the folate trap? That people found that when you give folate, especially to pregnant women, this has to be accompanied by B12. If you don't, it not only fails to correct the neurological complications, but it may actually make them worse. And this is called the folate trap. And the third, these two, along with something called adipocyte formation, I won't go into that in detail, but that refers to the formation of fat cells in the body. Okay, so Indians have particular types of fat cells. These three form a kind of like a triumvirate, if you like. They're a regulatory hub that control NCDs. And they're all major problems in Indians. Which leads us on to, well, how is the fetus prepared? So I'll just pause there for a minute. If the fetus never came out of the uterus, never, hypothetically, it would almost certainly not develop an NCD. Okay? Of course, we'll never know that for sure, but the chances are very high. It's because as soon as the fetus emerges, it's exposed to all sorts of things. So the fetus needs to be prepared. What happens when the preparation is insufficient? So a couple of the important things you should know here is the epigenome. What is the epigenome? Everyone's heard of the genome. So I liken this to a light bulb. So the amount of electricity reaching the light, going through the circuits, is the same in every household. But the amount actually reaching the light bulb depends on this dimmer switch. And that dimmer switch is the epigenome. It controls how the DNA is expressed. That's a very simplistic explanation, but it works. Okay. And we're indebted to this man, Conrad Waddington, who long before the double helix of DNA was described this. It's called the epigenetic landscape. So the little ball you see at the top is a primordial germ cell. It's just formed in the ovary, okay? And it's rolling down this landscape. But this landscape is different in everyone, okay? So it can, depending on how the landscape is formed, it can go one way or the other. And even siblings have different landscapes. That explains why one sibling can have type 2 diabetes, another can have just obesity without type 2 diabetes. Here's something to think about. And you can ask later, I'm just planting the idea. Babies conceived at different seasons may have different birth weights. This is a very famous experiment or study that was done in the Gambia, okay? And there are very good reasons for this, which we can talk about. From the same mother, by the way. So here you have maternal and paternal influences, and most of the time they disagree, okay, as you might imagine. So the placenta has to try and unify them. before they reach the fetus. And these are called imprinting. Okay? Most of the time it works. Okay? So you get a nice, healthy baby. But sometimes it doesn't. So here you have an undernourished mother who's obviously looking worried because she sees an undernourished environment. So she gives birth to this thin baby, and this is called a thrifty phenotype. A phenotype is the outward expression, okay? So this thrifty phenotype is a predictive, adaptive response. In other words, the placenta looks at the environment and tries to predict what's going to happen and programs the fetus accordingly. But like most such responses, it doesn't always work. Now, if the baby continues in a nutrient-poor environment on top, then that's a survival advantage. But the minute this child comes into a nutrient-rich environment, there's increased susceptibility. So there's a mismatch between the environment that has been programmed for and the actual environment, and this results in maladaptation. So fetal growth restriction, low lean body mass, thrifty phenotype, low lean body mass. So the Indians are small and they have small muscle. That's what's meant by a low lean body mass, okay? But in addition, Indians have this unique phenotype, South Asians actually, not just Indians, called the thin fat phenotype. And what is that? Well, for this, we're indebted to this man, Chittaranjan Yagnik, who is a diabetologist. He works in Pune, and it took 5 years for him to get this paper published. Nobody believed what he was saying. But basically, he showed that Indians have this thin fat phenotype. And there are all sorts of contributing factors like maternal nutrition, gestational diabetes, and air pollution. And they all result in maladaptation. Think of it like a motorway. What's the thin fat phenotype? So you've got a 3-lane motorway, normal traffic, everything's fine. In the thin fat phenotype, the third lane didn't get built, okay? But the amount of traffic remains the same. So congestion builds up, but somehow they manage, okay? So that's the thin fat, but the minute you get some sort of environmental stressor, the traffic builds up dramatically and you get maladaptation. That's just a very simplistic description. And Yagnik and his colleagues from this very famous study called the Pune Maternal Nutrition Study showed that these children, thin fat phenotype, had a normal BMI, but insulin resistance at every age, a higher systolic blood pressure at every age, and a higher body fat at every age. And this was associated with a low B12 and a high folate. That's the first time in the world that this was described. It's a seminal study, actually. So the thin fat phenotype is a manifestation of thrift. The child appears slender, but has a relatively high body fat percentage, easily missed. It's seen even in Indian babies who are born abroad, okay, and born to affluent mothers. So you've heard of Indians living abroad, even born abroad, with a high risk of coronary artery disease. This is why, or is one of the most important reasons. So that's the thin fat phenotype. And this is a very famous picture. It's called the YY paradox. And that's Chittaranjan Yagnik on the right, okay? And that's his European colleague on the left. It's a bit fuzzy. They have identical BMIs, okay? But Chittaranjan Yagnik has 21.2% body fat, and his colleague has 9% body fat at the same BMI. That's what he was trying to illustrate, that Indians have relatively more fat. They're not actually fat. It's a relative description. What is important is that this can progress, the thin fat phenotype, to what's called visceral fat. That's when fat starts accumulating around the liver and the intestines, but the person actually doesn't look that much more obese. It's bad news, okay? But before that, remember, visceral fat may progress to truncal obesity. So there are a lot of people in India who have truncal obesity, but they don't always have visceral fat. So not everyone with truncal obesity has visceral fat, but individuals with truncal obesity and visceral fat are at high risk. Why is it common in India? Because you have all these problems in India. You have feast famine cycles, pollution, that is from the outside. And then from the inside, the three important ones are high prevalence of maternal insulin resistance, small muscles. Muscles burn glycogen or glucose, okay? So you need muscles. And maternal micronutrient balance. What is a micronutrient? Things like B12, folate. It's called the hidden hunger, okay, micronutrient deficiency. It's actually one of the most important reasons in India. But probably the most important reason is if the mother had the thin, fat phenotype as an adolescent. Indians have always had small bones and muscles. This we know from 10,000 years ago. Okay, examination of skeletons shown this. And this resulted from environmental fluctuations and feast-famine cycles and so on. And these fluctuations forced them to adapt. That's why, even though Indians came out of Africa, they look so different. But they didn't get NCDs, or at least the genie was reasonably well contained in the lamp. Why? So basically, the environmental changes initially were very slow. So the adaptive processes had time to evolve. But we sorted all that out with the Anthropocene, okay? The rapid changes in the Anthropocene have created havoc on this planet, like an obesogenic diet, pollution, and so on. And this has resulted in NCDs. What are the critical windows? The first 1,000 days, everyone knows. Preconception, sorry, first 1,000 days, I mean, including pregnancy, okay? Not after birth. Preconception, that is before conception. Very, very important. And adolescence. I keep coming back to adolescence because it's overlooked. Why is it important? Because during adolescence, especially in girls, the ovaries are forming the primordial germ cells. So that adverse exposure in adolescence may lead to the risk of NCD in their offspring. Very hard for adolescent girls to understand this. Even if the subsequent environment is stable. So even if the girl then moves somewhere quite stable, that risk is there for life. And you can see these two pictures. On the left is the Dutch winter hunger. So what happened? So in the northern Netherlands, the Germans cut off the food supplies to this area of the Netherlands. Why? Because they sympathized with the Allies. That immediately resulted in acute famine. It was one of the tragedies of modern times, but we do have long-term data. It's one of the sort of offshoots. And similar results are probably going to be seen in survivors of Indian famines like the Bangalore famine. Unfortunately, we don't have similar data from India, which is a pity, but we can only extrapolate. I just wanted to clarify what multi-generational and transgenerational are. Multi-generational is up to the grandson. Transgenerational is beyond the grandchildren, great-grandchildren, and so on. There are various interventions that we can look at in pregnancy and adolescence, lifestyle, GDM, micronutrients, and mental health. By the way, I think people should understand that exercise reduces insulin resistance within hours, okay? So a lot of young people come say, oh, well, I go to the gym and I've not lost weight and so on. You have to tell them that actually it's been reducing the insulin resistance within hours. And that's because the muscles have exercised, nothing to do with their weight. So even if the weight doesn't change, their insulin resistance has already started falling. Now, there are many countries in which these have been applied. Chile, for example, have integrated the sort of DOHaD awareness into their sort of regular monitoring programs. New Zealand have got these camps for the Maori population in which they include awareness. For example, we have this in India. In Chhattisgarh, there are melas, for example, in the tribal melas where you have little booths, and there they can sort of have some counseling. And in the UK, there is this concept of the saying, actually, it's quite a nice thing, making every contact count. So every time you come into contact with someone who's vulnerable, talk to them about DOHaD. This happens across all clinics in the UK now. So the genie has now been let out of the lamp. It's very unlikely that we're going to get the genie back in. What can we do about it? Well, that's what we're here to discuss. Thank you very much. So with that, let's move on. Let's begin by asking you, we all know about smoking, but pollution is not just about smoking. It's about so many other things which have far-reaching side effects beyond the lungs. And in particular, we know that the placenta is uniquely susceptible to pollution. Can you tell us about this and about the mechanisms involved?
Sure. First of all, thank you so much. It's a great pleasure to be given this opportunity. It's not very often that we get to get a chance to discuss our science with the general public. So very much appreciate the opportunity. And also for this introduction, as you can quite imagine, this is already a Pandora's box unleashed. It's not going to be easy to sort of explain every single part of risks like nutrition, diet, exercise, physical activity, that we have a measurable sense of what we are being exposed to and how it impacts. So you throw in things that we can't measure very easily or understand what we are even being exposed to. It's quite a different ballgame in terms of piecing all these evidences together. So, Dr. Vellodi, I want to sort of begin by, when environmental health epidemiologists like me try to ask ourselves this question, why do we think it's the environment and not genetic? Because we are wired to think that everything in the developmental period is so predominantly genetic. The very influence of environment actually starts once you come out of the womb. While you're in the womb, you're safe, because no matter what you do, you are somehow protected against. That's the perception or that's even some of our formal trainings that we received. Don't think of pregnancy related environmental health insults. Think of, thalidomide, or think of, DDT or diethylstilbestrol, drugs that form deformities, reduce those kinds of disasters drugs. But rest of it is fine. You eat healthy, be healthy, and so forth. So one of the most important things I think, that changed our perception is what you alluded to. NCDs have started astronomically rising in the last 40 years. And that's too small a time frame for any kind of genetic variations to even accrue. Fundamentally, this changed, even, I guess, 40 years ago when I was a graduate student, where I was beginning my graduate school, we weren't trained to think that you could actually think of this. The NCD pandemic or the NCD epidemic had not even unfolded back then. But we were sort of, so that the principle number one on why environment is important starts with thinking right there. I'm not sure if this right there works. So you can see the DNA here. It's fixed. Nobody's denying that. But what's really happening is right there. The DNA is fixed, but the DNA expression can be changed as much by nutrition. We know that now. But what was new up until very recently is whether it is undernutrition or overnutrition or exposure to pesticides or smoking or alcohol or air pollution, it is all the same thing. As far as this DNA is saying, what it's seeing is to change its expression in such a way that it would confer a fetal advantage of being born to near normal weight, not even low birth weight, and somehow try to protect the fetus for survival. But in the process of doing so, you are setting yourself up for already early life deficits and later in life outcomes. What over or undernutrition does is what your phthalates do, what your bisphenol A in plastics does, what air pollution does. And that has been a magical progression in terms of our understanding. And if you can look at the earliest history, the earliest environmental stressor we knew to make pregnant women stop insulting their bodies was smoking, as you mentioned, Dr. Vellodi. And there you go. You have here. I'm not sure if you can see this graph here. Oops, sorry. If you can see this graph here, this is the blue line for weight of boys and girls born to mothers who don't smoke, who didn't smoke during their pregnancy. And just look at the lines here for boys and girls who were born to mothers who smoked. What Dr. Vellodi was mentioning, obesogenic insult that smoking produces, essentially is through mechanisms that control gene expression or epigenetic modifications that go not just with your own offspring, but if they were to be targeting the germ cells of the offspring, has the capacity to cascade across other generations. And if you are kind of wondering, okay, that I get it for smoking, that's an insult that we all recognize. We've seen actually babies being born with low birth weight with smoking. Could this be even attributed to air pollution? And those of you who are in Bangalore, Chennai is at least a little shade better. But if you're looking at Delhi, those of you who have just come back from Delhi or trying to, nobody wants to go to Delhi. And there is a genuine risk of not just adult morbidity and mortality resulting from that. We increasingly now know why air pollution is and could affect affect birth weight or a whole range of maternal consequences. So if you can look at smoking from the cigarette, from the stack of an industry, from a chula, from the tailpipe of a car, it's the same deal. The dose is different. But what triggers that placenta to sort of rewire itself tells the placenta, look, I am not okay. My fetus is not okay. You better do something about it, because otherwise, if you don't do something about it, my child is birth weight is going to be impacted. So essentially now we realize that this particulate matter that is smaller than the blood cell, this looks like an asteroid here, but it's actually much smaller than the blood cell, can enter, not, even if you're inhaling air pollution, as Dr. Vellodi was mentioning, it is not about respiratory morbidity. Because it can enter your blood cell, can cause a whole range of health effects, either directly during adulthood or through the placenta. This, I cannot explain the imagery of this. This is a picture of the fetal side of the placenta, where we are now able to actually document black carbon deposition. Black carbon is a constituent, or some of the most dangerous constituents of particulate matter, inorganic components of particulate matter that are sitting. That's how much science has progressed. So it should, normally if you say air pollution and birth weight, nobody is going to believe you. it's a very, long, convoluted, conclusion in people's mind, because you think nobody is dying, dropping dead in front of your eyes. At least smoking, you can sort of, the dose is different, but the overall population impacts nevertheless is, incredibly greater. And just one more example before I have the so this is, if you're talking about air pollution, all the plastic related products that you think here, persistent organic pollutants, pesticides, from textiles, bisphenol A, endocrine disrupting chemicals. By their very name, you can think if it is endocrine, that means it is related to some kind of metabolic perturbation. We now understand the mechanisms in so much detail that we think that whether it is environmental chemicals or nutritional imbalance, it is just two sides of the same coin. Bad nutrition is the same as bad environment, whether it is overnutrition or undernutrition or anything else, because these environmental chemicals are, after all, mimicking what a bad nutritive pathway or what a good, over nutritive, bad nutritive pathway, whether it is under or over nutrition, would actually entail. Same epigenetics, same long-term effects on gene expression, same level of increased disease risk. And therefore, these, mechanisms can not only be multi-generational, as Dr. Vellodi was saying, it can be transgenerational as well.
Thank you. So that leads us very nicely to the next question. We're talking about successive generations. We need long-term data. And is there any I know there are several studies in progress. Is there any useful evidence accumulating now from these cohort studies?
Indeed, so if you're sort of looking, if I may just backtrack one moment to sort of look at, cohorts can study a lot of things. Cohort essentially means that you recruit up, a person. It could be a pregnant mother, it could be a young child, it could be an older person, and then follow them up for 20, 30, 40 years. So one question when we started environmental health cohorts some 25 years ago, I have several of my young colleagues who have aged with the cohorts here in the audience. And we had to ask the question, what do you prioritize? Where would you start with? Because you could do endocrine disrupting chemicals, you could do pesticides. What do you maintain surveillance on? So one of the things that sort of is currently going on here in India is to sort of really be able to answer the question on environmental hazards that are some of the most pressing concerns of today. And this slide basically illustrates that this is a listing of all the risk factors that is contributing to the maximum amount of NCD burden, the maximum amount of disease burden in India. So you can really recognize malnutrition and air pollution being at the top of the risk. And now that we have all this mechanistic understanding, it should not be so surprising. But we actually produced these risk factor rankings well before we knew the mechanisms, because epidemiologically, that's what we were observing. We were finding that people, in higher exposed air pollution environments were of lower birth weight. So given that air pollution is a priority, I'll just give you one example of an ongoing air pollution cohort that our own team has been engaged. One of the things that we have to ask ourselves, how well are you equipped to monitor all the things that you need to monitor in the cohort, right? Just with air pollution, you have 15 different parameters, or 150 different other things in blood and urine to monitor. So this is one example of a difficult to reach population in rural areas that are dependent on biomass cooking fuel. Something as innocuous as that. We all think, my grandmother lived to 70. What is wrong with the chula? My rasam tastes very nice on the chula. What is so wrong with my chula? Wood is natural. What is so wrong with wood smoke? All these questions are just, total factoids or totally myths to be busted. If every grandmother of India lived to be 80 or 90, our median life expectancy would be 85. Our life expectancy is just, inching up to 70. Everybody's grandmother did not live to be 80. Yours and mine did. Maybe we were lucky to have a grandmother, but not all our grandparents lived to be 85 either. So this whole myth of household air pollution is now being addressed in a very, very systematic way. And this is a trial that we just concluded in 4 countries: India, Guatemala, Peru, and Rwanda, wherein we intervened with a clean energy intervention for household air pollution and monitored every possible thing that you can think of for air pollution. And lo and behold, you will be surprised, after investing nearly $30 million from US grants, we found a null effect for the intervention. We should have been wiser, right? Knowing all these mechanisms, we should have expected the intervention not to work by intervening by the 4th month of pregnancy. All these epigenetic modifications in the biomass community homes, we didn't find any difference in that. But we did find many other findings that point out to mechanisms on how this air pollution is acting. But essentially, trials are not going to provide you the answers in the time frame that we are talking about for DOHaD. If you're looking at 10 or 20 or 30-year transgenerational effects, you need actually natural observatories to be monitoring populations and really creating this evidence going forward. If I may, just one, I know this is a lot of detail to sort of really absorb, but I'm sure we can all recognize. I think, the non-trained environmental health specialists, or people from other disciplines get it a lot better than we do. We think we have the ability to measure a precision, chemical at trace concentrations in saliva, blood, serum, placenta, whatever. And somehow that science is going to change the world. Whereas any person who's living an everyday life would say it really doesn't matter. If you just had the ability to measure one, what about noise? What about my drinking water? What about my food? What about my plastic? What about my commute? What about my stress? What about my BMI? So we now recognize single exposures are useless to monitor and make any kind of decisions. So the future for the DOHaD framework and for our field going forward is exposomics. I won't try to, we teach a semester-long course, in fact, a whole degree course in exposomics. So obviously, it's not going to be easy to sort of parse out the whole detail. But I think we all understand all of these things matter. But the goal of all the exposomics is not to collect a whole lot of data and to sort of really mine it to the highest degree of precision. It has to translate into what we call not just into personalized medicine to cure diseases, but to precision prevention, where you can target communities, individuals, and groups with information that can prevent these combinations of exposures in a targeted way. If you say go back to pre-industrial times, none of us are going to be able to do that. We have to give pragmatic choices. What can you do in Koramangala? What can I do in Annanagar in Chennai? Or what can I do in the tribal hill population of Nagalands or Assam? We have to start creating exposure atlases. That is very much work in progress, both by the Ministry of Environment as well as by the Ministry of Health and Family Welfare. But I'm not sure, I'm not perhaps the oldest person in the room, but I'm pretty old. There are youngsters. Hopefully by their lifetime, we will see some of these things being generated and being translated into pragmatic guidance.
A couple of things that have arisen from this. One is, of course, that there are certain target groups that we have to sort of try and aim for. Women and adolescent girls. And so, Naveen, how do we target these people? And in particular, how do we target adolescent girls? What has been, can you combine it with anything that you're doing?
Thank you, sir. Thanks to all of you for taking your time out. And thanks for this team of people who are from different background who have been called to talk about DOHaD. And all the slides and pictures are from the Ministry of Health and Family Welfare, RMNCHA plus N. That's where I've taken all these diagrams from. So this population is based on the 2011 census. So I put this up because if you look at what we have been, the two previous speakers have spoken, there's a lot of opportunities at every stage in our life cycle where we can do an intervention. So this tells us about the total number of pregnant women, because that's where most of the things do change to happen, especially if you're looking at the next generation and looking at preventing the next generation, or probably reducing the burden and the risk. So that's the number of pregnant women we have and the number of births and the adolescents. So looking at the opportunities, this is what I said. So if you look at the programs which have been done or taken up by the government of India, most of it have been, even though they don't say that it's going to look at DOHaD, there are some small interventions which have been done, which we can relate it to probably on a long-term basis looking at DOHaD. Because currently malnutrition, undernutrition among children, or anemia are the major problems which are affecting our country. And that's what the markers are looking at, or that's where we compare the Indian statistics with other countries. So that's what they look at a bigger picture. But if you look at the micro things, there are a lot of things which have been done. Looking at the reproductive health, the small thing like spacing between pregnancy so that the nutrition level of the woman comes back to normal or to closer to normal between two pregnancies. R is for reproductive, M is for maternal, that is the pregnant mother. There are a lot of programs which look at pregnant mother starting from early registration, so you can assess for the risk factors, iron and folic acid and calcium, which definitely you would have heard about it, vaccination. Mental health is also being taken care of. How one is the fund transfer to the mother, even giving transportation from the village to the hospital and taking her back, and making sure that the pregnancy happens at an institutional level rather than at home. N is for the newborn. As soon as a newborn is born, apart from being born in an institution, you look at the nutrition status of the newborn. And apart from the congenital things which goes into clinical, we are also looking at the nutritional status of the newborn and looking at vaccination so that you can protect the infections, screening for children. So those are some of the things which happen at that time, including early initiation of breastfeeding. And now most of the industries do give 6 months of leave for the postnatal period so that the child will be able to get the nutrition, which definitely have some of the protective mechanisms which from the mother can be to the child. C is for the child. Apart from immunization, you have RBSK, which looks at the important Ds, that is delay in nutrition, delay in achieving the milestones. They're picked up during screening in the Anganwadis or in the school, and they get that special attention. So that's what we're looking at. And diarrhea, you might ask me why diarrhea and ARI are still looked into the infectious diseases, but they are the most important cause of undernutrition of children and also death. Then we have the adolescent, which is very interesting, and then probably a age group which was not touched upon for a long period of time. Now, a lot of interest has been given to the adolescent age group of 10 to 19 because we had looked at children, we looked at the reproductive woman, which starts at 18 to 49. The adolescent was, for a long period of time, there was a lot of gap for the adolescent. But we know that adolescent age is also a formative year, both in terms of their health, the mental health, and the habits which happen during that period of time. which can have not only impact on the mother or that girl, it can also have an impact on the child when she becomes pregnant and later on the health. So a lot of things are being done at looking at the adolescent age group. Some of the things I've given here. And the last one is the nutrition. Still, nutrition continues to be a problem in our country. We call it as the triple burden, where there is nutritional deficiency. We still continue to have infectious diseases, which still continue to trouble us. And now we are having the highest burden of NCDs. So that's the burden which we continue to have as a part of a part of this programs, which target, as I told, not exactly DOHaD, but yes, long term they will definitely have some small benefits on DOHaD.
Thank you. And I mean, we'll come to that. I think you're going to, in your next slide, you talk about it, but how do we raise awareness in these groups? What are the opportunities? I mean, these are the opportunities in as far as maternal health is concerned. As you can see, there are a whole lot of programs going on with women. But if we go on to the next slide.
So this is the programs, as Sir mentioned, and then every time the woman comes in, many times a lot of us on the health profession are looking at treating rather than looking at the long-term consequence. So DOHaD, probably many of my colleagues will not know what's happening for DOHaD, except for a few, for example, Anurag Krupad or the Korean, which they have come out with the papers. But many of the doctors themselves will not know about DOHaD because it's not been a part of our medical school. But every time there is an opportunity for us to look at DOHaD and then talk to them about the opportunities through these programs. These are the nutritional interventions. Ma'am did speak about the environmental factors, but nutrition also have a place to play. One is the epigenetics, where the child in the womb or in the uterus is looking at, okay, I'm going to come to, it's going to form a protective layer against itself. But when it comes out to a place where the nutrition deficiencies are there, it will be able to adapt. But it comes into a place where there's nutritional excess, that's when we're going to have a problem. So, but as I told you, this also only looks at nutrition at a larger picture, but not looking at whether the child is going to come out to a normal environment or it's going to come out into a stressful environment. So, but yes, all of them look at improving the nutrition status. We hope that this improvement in nutrition status over a long period of time, over the next few generations, will help in improving the outcomes, and we also have better scientific knowledge. But now questions have been raised. Should we give vitamin A syrup once in 6 months? It's been a normal routine. If you go to any place, every 6 months till the child reaches 5 years, the child gets vitamin A. Now the questions have been asked, does the child need vitamin A? Other one is anemia. We have iron and folic acid, which has been given to the pregnant women. Very rarely we look at vitamin B12 and folic acid. The foliate trap is important. Yes, iron and folic acid, we have a combination, but we do not have the vitamin B12 component of that. So is it worsening the condition or is it really taking care of anemia? So that's where the nutritional interventions come into play. I think the next one is on the reproductive health, which is looking at the population, the temperature and spacing.
Yeah. Well, we can go on to the next slide. Yeah.
I think this is the adolescent health.
So the adolescent group is a particularly vulnerable and neglected group. The question is really whether, because adolescents, they don't understand these things, and it's very difficult to talk to adolescents about something that lies in the future like this. They have other things to think about, education and marriage, all sorts of things. Starting to talk about DOHaD is, so we've got to have a way of getting through to adolescents, and many programs across the world have used what are called peer educators, PEs. That is adolescents who can actually speak the same language. And it's been shown that the results, when such people are used, are much better, the results of raising awareness. But you've really got to use a language that they can understand. You've got to employ people whom they trust and whom they believe. So I think the RKSK is there on paper, but the results of the RKSK in India are really patchy. If you look at adolescent awareness, it's very poor. Okay.
So what we look at as the program talks about having an adolescent-friendly clinic in the existing system. That is our primary health centers in rural areas. But what's happening is, are they really adolescent-friendly? Is the question we'll have to ask. Because the timings of the hospital is between, most of the times it's between 9 to 5. Do you know that most of the adolescents are either in the school or colleges between 9 to 5? One. Two, it's one medical officer and a lot of people sitting over there. If they really want to talk something which is personal, are they really having that space to talk about those things? So what's happening is the adolescent-friendly clinics are on papers. Micronutrients to some extent are taken care of. The RKSK is, even if you look at the details of this program, they're looking at holistic development of an adolescent. That is their menstrual hygiene, the nutrition, the education, misuse of drugs or alcohol is what it talks about. That's one of the biggest program with regard to adolescent. The next one also looks at empowering an adolescent with regard to skilling them so that they will be productive going forward, but they'll be able to take care of their health, but definitely not looking at DOHaD. Probably because even when we try to explain it to anybody, they don't see that happening when they have a child. It's going to be a long-term impact. Probably they'll understand that 30 or 40 years later on, not that which they're going to see now. But if there's a nutrition deficiency, they want to see a child which is born low birth weight, which is having an immediate impact. So probably that's where the gap is between explaining DOHaD, which is a long-term consequence, when compared to something which is easily visible to the adolescent.
Thank you very much.
Thank you, sir.
The first, as you've probably gathered, is the lack of awareness, even amongst health professionals, of DOHaD. I mean, in a sense, we don't actually have to use the term. It's a catchphrase, which is convenient, but actually it's about the principles of DOHaD. It's about the principles of DOHaD rather than the term itself. That's important. The second thing that I just wanted to mention was the title of this program, Born Vulnerable. Now, some of you may be wondering, well, if the mother or the placenta is trying to protect the fetus, why are they vulnerable? These children are vulnerable from birth. So these children are born with insulin resistance. Whether they go into a good environment, bad, they still have insulin resistance. Why is that? It is actually not protective. The placenta cannot distinguish between health and disease. It's incapable. It's not sentient, okay? So whatever is going on inside the body is what we call a complex adaptive system. So what is a complex adaptive system? It's a group of processes that work together to achieve coherence. That's it. And that's all the placenta cares about. As long as there is internal coherence and balance and the fetus has survived, that's fine from the placenta's point of view. The mother has no control over this. So it's not, so the placenta can mechanistically see, but it cannot cognitively see the future, okay? And therefore, that's why they're born vulnerable. And no matter what else happens after birth, it's not the placenta's concern. So I just wanted to clarify the title. Okay, I think, so now can I invite my co-panelists and we'll.
Two questions. One is everything we talked about has to do with either female adolescents and their development of ovaries and so on, or maternal health and all. So basically, you're saying the male doesn't matter, right? Can be undernourished, can be exposed to pollution. It won't make any difference to the child. I'm not trying to be facetious, but serious. So male nutrition and male exposure to pollution doesn't seem to matter. Is that correct?
That's not it. Well, it's less important, should we say? The importance is less than that of the mother. It's not that there is no influence at all. I mean, sperm counts and so on, for example, are well known to be affected by pollution.
If I may, answer this in a different take, it's like you may not be able to influence too much your offspring, but you yourself are a product of what your mother saw. But on the other hand, you do have a contribution to make in terms of, if you follow an unhealthy lifestyle and your epigenetic modifications are such that they play negatively into your partner's epigenetic modifications, even though it is the DNA of the two partners that eventually make, there is increasing evidence that some of the epigenetic signals of unhealthy lifestyles or unhealthy states of the body of the male member can actually, it's really hard because you need longitudinal data, and these modifications are very small, and then you have to go through zillions and zillions of modifications before you can really pin this down. But it would be a great help if the male members followed a healthy lifestyle too.
Sorry, the second question is, you briefly mentioned that there's a difference depending on the season, right? Now, as we know, many animals only produce in a certain season. They have a seasonal reproduction. So this is seeming to indicate that somewhere along the way, our behavior is incorrect. We should only be reproducing in a particular season. Is that correct?
Well, I don't know about the interpretation. So what you do about that's what you do about it. But you're quite right. So this is the equivalent of runting in animals. So cattle, for example, who conceive in the wrong season, produce runted calves. Very similar. But the experiment that was done in the Gambia showed that mothers who conceived in the lean season, the rainy season, conceived, not gave birth, conceived, gave birth to babies that were slightly lower birth weight than mothers who conceived in the dry season. And the reason for that is something called it's epigenetic. It's called a metastable epithelial, which is sensitive to the climate. It probably exists in India as well. There is some data coming through, and you can, for example, babies conceived in the stubble burning season. Would you like to?
Well, every pollution exposure is very much influenced by, often the fate and transport of environmental chemicals is influenced by meteorological parameters. You have more water runoff, you have more air, shed dispersion. So there is a gray, very, in fact, almost in every environmental health study, we have to adjust for the season at which it was measured. If you ignore the season, you are missing a window of exposure. So that is an over and above, whatever there is a baseline indication. So, and the same is true for nutrition too. So I guess this complex interplay of nutrition and environment is probably the primary signal, overlaying itself on a longer term evolutionary trend. How is that playing into in terms of, did people, for example, have an evolutionary advantage because, they appeared, if it was not too cold, not too hot, did the natural geological cycles of the earth play into when a baby was conceived, and what which offspring survived, that kind of a question. Lots of things too that we don't know yet.
Okay. Thank you to all three of you for excellent overview of DOHaD and also what can be done with the existing problems which we have and how we can sort it out later on once the child is born. I'm a physician. I'm also already seeing a lot of people at a younger age coming with cardiovascular disease, and the burden is increasing at a younger population. And thrifty gene is probably one of the causes of it. We got lean people, apparently look healthy, but they land up with cardiovascular disease at a very young age. So one thing about targeting the adolescents is very important. But there are some problems with adolescent. It's actually the age of adolescent is falling between it's a gray area. It's neither in pediatric age group or nor in the adult age group. So there is a lot of overlapping and probably they are not, that focus on adolescent is not there as of now in our country, especially in government setups, even in AIMS and PGI. I think they don't see children, pediatricians are not seeing beyond 14 years of age. And in, of course, the adult medicine starts after 18 or 19 or something. So that's a gray area which we have to tackle probably by some other means. And number two is the adolescent age when we can make the maximum, say, difference. That is the age when they are in 9th to 12th class. And at least in South and even in North, they are just bombarded with coaching class. They are just going from morning to night to the school. There is no way we can intervene in lifestyle in that age group. So that's a crucial age which we are just losing because of poor lifestyle decisions which they make. And that impact which I see in that age, all the weight gain or the lifestyle changes which they do at this age, it carries on till their 20s and 30s and all. So somehow we have to make a difference in that age, and that has to be a policy decision which has to come from the top. And also we should have some amount of, say, peer network or something beyond the physician, conventional physician or hospital or a healthcare setup of network.
Yes, sir, I agree with you. As we spoke about, that's a period when they are in schools or colleges, and our adolescent-friendly clinics definitely are not benefiting them. We did try having a small clinic in our hospital which was open after 4 o'clock till around 7 o'clock. But once again, picking it up was a little different because they have to come with their parents. Then the privacy, other things did not, and as you said, the classes which they go beyond the class hours was another thing which was hampering. So it did not go off well as we had planned. But definitely that's the age group when they pick up many things which will have a long-term impact. And added to that is the young heart, the cardiovascular disease in the young age group. Many of them are nowadays blaming it on the COVID vaccine or the COVID infection. Yet they might have started an inflammatory response, but definitely it's not just that playing a role. As we all know, there are a lot of determinants of health which have played a role, and definitely the adolescent age group is one which we need to target going forward.
If I may also add, no, it is also the age group for which we have the least amount of exposure data. Because it's very hard to target, to get their consents, exactly for the reasons. Parents will not give consent for an adolescent participating for any monitor that we want to put to monitor exposures, either because they have school or because they have coaching class or because they are just not, you can't convince them to get an informed consent. Pregnant mother was a very hard age group some years ago, but we have now mastered the art of. But now, these days, if I may say so, technology for wearables is really progressing towards being able to see signatures of exposures. And also, I'm not talking about chemical exposures or, those kinds of things that are much harder to do. But even lifestyle insults that they get, whether it is whether they are getting enough physical activity or whether they are getting enough sleep, or whether they are getting, are they are stressed, or is their blood pressure fluctuating. So we are in the process of adding on sensors for relatively seemingly innocuous exposures, both in terms of chemicals as well as other kinds of physical hazards. So the day is not far off where your smartwatch will have the capacity as a tool to intervene in adolescence, because you have the data to say. Because most of the time they say, no, I was sleeping. I was not stressed. I wasn't on the screen. My blood pressure was fine. You don't have the data to prove it. So if you have the ability to monitor, longitudinally as well as non-intrusively, we have a whole ammunition available for adolescent health that physicians like you can take great deal. I mean, essentially, the idea about this conversation that Dr. Vellodi, the future is not going to be just environmental chemists sitting and analyzing in the lab and, epidemiologists looking at this conversation. It has to be sort of, this whole data exchange has to be fertilized in a very, very active way, wherein physicians, community practitioners, and laboratory and molecular epidemiologists like us come together to sort of understand what the data is telling us and intervene.
So I have a question, but before that, I had just one comment to add on this adolescence interventions. So one is, I think, our entire educational system and the pressures it brings in and all that will not permit adolescents to use outside, what they do for the normal curriculum to go and, seek interventions. I think it's highly unlikely. I think you have to find interventions during the time they spend at university or at school or high school, university, college. It has to come in a little normally. I don't, running courses on DOHaD kind of areas may not be interesting enough for them. But how do you build it into something which they do every time? It has to come in from there. And I think we are in such a mess anyway about the stresses and pressures we are creating in that system that this is not going to come. So, I mean, we have, I think, to address it at multiple levels for it to make any impact. The other question was more about, again, this born vulnerable thing. So, you said the 50 phenotype was essentially protective. And it's meant to be protective, but ends up making you more vulnerable. Is that because we now live longer and, the protective period is only the short term, and but that creates its own genetic issues or epigene consequences as you age, and there's certain other things happening because that I recall reading somewhere about some diseases which have come which earlier actually provide good protection in the pre-40s, but then if you live beyond 40 or 50, then they turn out to be problematic and create other things. Or is it that these people?
Well, okay, so the first thing is that we don't know how long Indians have had the thrifty phenotype. We know from examination of skeletons going back 10,000 years, so that's almost to the beginning of the Holocene period, that Indians had small bones and small muscle attachment points. So they could look at the bones and see where the muscles were attached. Obviously, you can't test the muscles, but we can extrapolate that they had small muscles. But that's only going back 10,000 years. Indians came out of Africa, 60, 70,000 years ago. We don't know how far back, but we do know, if you look at Neanderthal remains, there is evidence that there was atherosclerosis in Neanderthals. So it's not that NCDs didn't exist in the past at all. It's that the environmental conditions have gradually changed, and they've changed at the rate at which they've changed has been much more. That's the point. So, for example, in ancient times, if you look at 5,000 years ago, you had what's called the ENSO. ENSO stands for El Nino Southern Oscillation. This is a sort of climatic variation which was there, which was definitely climate change, but it was pretty gradual. So people had time to adapt. But what's happened in the last few hundred years has been so dramatic that we simply can't keep up. So any intervention it's going to take ages for us to see any. So we shouldn't get impatient with our governments to say, well, this is not working or that is not working. This is, so I don't have an answer to that question. How old is the thrifty phenotype? We can only say from the skeletons we have so far. If you look at this is South Asian skeleton. South Asian skeletons have increased in size over the last 10,000 years, but they are still small when compared to global skeletons. Okay, that's all we can say. We can only tell you what data is available and what has changed recently, and what we can do about it, or should do about it.
If I can add two more things, what the recent trend, what we are seeing is you can also, a lot of books or research is going on is the migration. A migration from rural to urban areas, which has increased over this thing. Will that have an impact? Because they were into agriculture, hard work, labor. Now they're coming into a situation where most of the things are where you sit and do a thing. The second one is our food habits have changed, where we are eating more and more into processed food, which we all know that it's going to have an impact. So nutritionists are also looking into these two things, whether it's going to make the things worse going forward or it's going to improve. But it doesn't look good as of now with these two additional changes which are happening over the last probably 100, 200 years.
And to add to that also, I'm basically at a higher level of confusion after listening to this whole, which is not a bad thing. I remember I had a coach or mentor. Okay. I'm always accused of having a loud voice anyway, but you need it for, okay. But one of my mentors used to say, I hope I've left you at a higher level of confusion. So it's not a bad thing, but to your point, there's also, when I live in the US, and when I went to the US 45 years ago, we definitely had seasonality in terms of what we could eat. Today, I can get any fruit, any vegetable at any time of the year. And there has to be some, and that's happening here too, right, in India. So you're not eating what's grown locally. You're eating stuff that's coming from hundreds of thousands of miles away. But getting back to the whole topic that we have, so there's an awareness. They always say the first thing to solving a problem is awareness. But there doesn't seem a resolution to it. And so how do you, for example, Ravi's point about adolescence, I was involved in a program with adolescents about crime, fighting crime, in a small city in the US, Milwaukee. We brought it to the school. Rather than taking the kids out of the school, we brought police officers and immersed them in the school and made it a part of the curriculum, where they had a class once a week where there were police officers standing and teaching them about crime. And it had an amazing impact over a period of about 12 years, where kids who were trained to run away from the cops, and these are inner city high crime areas, started embracing having police in their neighborhood. So to that point, yes, bringing the programs into the schools. But the interesting thing, you all were talking about adolescent pressures here being about academics. In the US, it's completely the opposite. It has nothing to do with academics. It's everything else, social pressure, peer pressure. It's about adolescent sex, birth rates, all that, drugs, alcohol, everything. So, but when you don't have, and it's going transgenerational, how do you even relate, even if you bring a program to the school, how do you get a child to pay attention to something that may not affect them, their children, or their grandchildren?
I think so that's a great question. That's the problem. And I think one may have to have slightly different approaches in the urban and rural areas. So, for example, the rural adolescent girls, I mean, the difference is not as marked now as it was some decades ago. But the priorities in the rural areas are slightly different, or one could argue, for example, biomass fuel use is greater in rural areas than in urban areas. So that's an area you could focus on in the rural areas. Whereas in urban areas, it's about very much about lifestyles, obesogenic environments, social pressures. We haven't talked about stress, but what's called the HPA axis is absolutely fundamental in DOHaD. And that is probably more likely to be a factor in urban areas. I'm saying probably, we don't know. Pollution may be different in rural versus urban. And I think that, one has to look at the population you're treating. That's what's called precision approach that Kalpana was talking about. You identify your group. First, you identify the problems, what the questions you want to ask are in that group. Identify the minimum number of, so if you want to do a study, for example, there's data now to suggest that 500 is a minimum number to do a study on, okay? Less than that, you don't see an effect that can be published. Greater than that is quite difficult to do the study. So 500 is a decent number. So you take a taluk, that is 500, and you do your study, but you first have to get you have to get the data for that and then design the study to fit, to answer the questions and really go from there. But I mean, I think the countries in which this has been the most successful have been those where this has been recognized for decades. And Chile, for example, is an outstanding example. They've integrated into their programs 40, 50 years ago. And it's been going on for years. I mean, I was bowled over by the results, actually.
And are they seeing results?
Absolutely. The results of type 2 diabetes has fallen, obesity has fallen. You look at the Maori population in New Zealand, I mean, that is dramatic. I mean, the results there, I mean, it really is a flagship program.
So is there something that we can borrow from those?
Without any doubt. Without any doubt. The question is, what is impeding that? I think the facts are there. It's all published. What is impeding that?
But how much is in the hands?
Yeah, that's the point I wanted to get at. Prevention is not something that an individual can practice without the support of the state or the overall ecosystem stakeholders. And the goal of this talk is not to put the onus back on the little kid who's sitting in the school competing against so many pressures and actually understand DOHaD or think that, DOHaD is what is going to hurt the kid that I will have 20 years later, and therefore I will engage in primary prevention. No. The best example we have, of DOHaD for a single hazard is that of smoking, wherein we tackled smoking over 50 years and the battle is still not won, where we looked at multiple ways of creating an ecosystem that actively discourages or, for that matter, eliminates smoke. Kids now, really, unless they are really wacko kids or, very, very under, attended to, don't want to smoke, not because they understand, and that has taken years. And that is not just a combination of people understanding the mechanisms of smoking damage to the mother, but taxation, creating economic incentives, understanding the health cost burden of treating smokers and so forth. So we do have lessons, and to Naveen's point of how challenging it is now, DOHaD is not standard of care prevention in India. This is just the beginnings of a scientific exercise in progress, and we really appreciate. Many of us serve on many of the national guideline committees. We are just beginning to understand and unravel the science. If smoking is so hard to wrap your head around, you can imagine endocrine disrupting chemicals. It's a very hard sell. How will you eliminate them? Where are we going to eliminate them? What do we know about the exposures? The risk is so small for an individual, but at the population level, air pollution, risk is so small for the individual. But for India, this is nobody in government, even in the Ministry of Health, when we present the results, is ready to believe us. How can air pollution? अब तो सारे ही लोग air pollution की वजह से ही मरेंगे. ऐसा थोड़ी ना हो सकता है. That's the popular refrain that everybody asks. Smoking, we get it, but this is a challenge. This is just, exciting science at this point. Really important science that can't wait for all of us to know all these answers before we take it for the public good. We have to start having this conversation now. The questions you ask tell us about, how we reframe our hypothesis. And therefore, the goal is to arrive at strategic epidemiological approaches and data synthesis approaches so that this translation of evidence to policy can happen at the higher level and percolate down to the lower level as soon as possible.
Okay, thank you so much for the presentation. I am a PhD student in epigenetics in the US. And so I was really interested to hear about the normal BMI type 2 diabetes, because in the US, it's mostly associated with high BMI obesity, which in certain populations is also associated with like famine, for example, in the African American community with slavery. So I'm curious if there have been any studies to show differences in the epigenome or the epigenomic landscape between people with normal BMI type 2 diabetes versus high BMI type 2 diabetes. I mean, I assume in India as well that is the case, but I just want
So there are studies. So I think there are two components to the answer. One is, yes, there are studies showing methylation differences between these two groups, and that's published, okay? It's a bit detailed to go into here, but yes, there are published studies. The second thing is, as I was mentioning about this epigenetic landscape, this primordial germ cell is coming down the landscape, this ridge. And at the bottom of the ridge are these things waiting, which we call attractor basins. And it's actually mapping the epigenetic landscape onto a complex adapter system. That's not been done yet. And that really comes down to a computational science, a biological computational science that's waiting to be done. But complex adapter systems are unique in having these attractor basins. So you could postulate that sitting in these attractor basins are insulin resistance, adipocytes, the folate, the one carbon metabolism, but in different basins. So depending on which way, so for example, pollution, there may be a particular attractor pulling into obesity, for example, or into type 2 diabetes. And it's just work. I think it's fascinating work because it offers an alternative way of understanding these conditions and possibly an alternative approach to treatment or management. I don't know if that answers your question completely. It's really.
If I may add there, since you're a PhD student, you should be able to pick this up. So the GWAS studies that really helped us understand the single nucleotide polymorphism landscape is being layered on to the epigenetic landscape and now to the EWAS landscape, or the exposure-wide association studies. So it's not just the epigenetic modifications per se, but also the underlying, single nucleotide polymorphisms that are
absolutely,
that the interaction or the crosstalk between the genome-wide associations, the epigenetics, and the exposure-wide associations is the elephant in the room here. It's like you can't really, begin to separate all of them. You have to sort of really integrate. And that's why we see unusual patterns. All our risk scoring for CBDs are breaking apart now because we are seeing different ways that these crosstalk to each other. And therefore, I can't, but, I wanted to make a comment. I saw William Conrad with a pipe cigar on the picture. And I was thinking, my God, he didn't think about DOHaD at that time, didn't he? So there you go. So it's like takes a long time to sort of really unravel these things. But yeah, this is the future. And I think the data science capacities that are building up across and being in Bangalore, maybe if any of you can convince, we were hoping that in Bangalore, we would have several of the IT folks come in and actually will, look at data sciences being the power engine to integrate these streams of data pouring. It's not going to happen without that. It's not going to happen without AI, and it's not going to happen without Bangaloreans.
And by the way, I was at an epigenetics conference last month. This was run. It was actually the National Genetics Conference, but we decided to have epigenetics as the theme. And the two groups of people had never seen each other. Really, I'm they're working in silos. It's extraordinary. We need to come together.
So, Dr. Kalpana, you talked about the exposure atlases. Exposure atlas.
Yes.
You mentioned I am nowhere related to medical community. In fact, I am a typical IT corporate. So I happen to be here. So I would really want to understand what can you share us about that, because that is something that maybe people in tech, IT, data science can contribute.
I'll just give you a small example of air pollution, and you can think of similar approaches being built for other kinds of exposures. So as you know, whether it is Karnataka Pollution Control Board or Tamil Nadu Pollution Control Board, one monitor somewhere sitting in some remote location has no correlation between where people are and where the sources are, and that was the case some 30 years ago. Right? Gradually, we ended up having 10 monitors, 15 monitors. Delhi now has something like 50 monitors. Even that is not enough to address the hyperlocal gradients that can happen in exposures. So now come the satellite products that we have. Now it is possible to calibrate the satellite provided aerosol optical depth, which happens, every day. At 1 kilometer by 1 kilometer resolution is the lowest point that we have been able to get. Of course, it is not without uncertainty. How can a satellite tell you what your exposure is? But we are getting amazingly close, where in compared to the cost of having every monitor in every home and everybody trying to interpret their own data, the cost of the satellite product is so cheap that you can actually calibrate it and get a very decent idea of what wards in Bangalore city or what wards in Tamil Nadu city are the most in need of attention, and we have source signatures from that. So we can now look at creating exposure atlases for pollution control boards for air pollution, which was imagine 1 kilometer by 1 kilometer, even in Bangalore is difficult. Imagine in rural Tamil Nadu or rural Assam, where even the capital city will not have even one monitor to do that. So that's how we are leapfrogging in being able to create exposure atlases. We have now similar dispersion models, similar biological monitoring repositories. You have blood samples from Chennai, Bengaluru, rural areas. We are now bringing all of them together, wherein we would do a multiplex analysis of the entire. It has been done in the US, it has been done in Europe, where we understand exposure profiles at very high resolution, and we will need the help of IT folks to map it with geospatial statistics to sort of really look at where are these exposures coming from and what are the choices for interventions.
Thank you very much. Okay.